So, what have we here? It's the SDK 85 System Design Kit from 1978 through quite a bit later. I think these ran into the 80s. A lot of electrical engineers use these in college. So, they cut their teeth on it. This is an 8085. Support chips right now. The most important support chip is the 8155, which has two 16-bit I/O ports. It's got the timers, and even more importantly, it's got 256 bytes of RAM. So that's all the. If you notice, there are no RAM chips on this computer other than what's built into the I/O chip. We have some ROM, which is running the monitor, and we have a keyboard and display controller controls the keyboard and display. So very, very simple computer. Again, you just got a CPU, ROM, an I/O with RAM, and a controller for the input and the output. And you got a couple of decoding chips. So let's talk about what we're seeing here. Right here, it's just a program that's running that's counting up in hex. That program is right here. It's called the 4-digit hex counter. I'm not going to pretend to be an expert in 8085 machine code, but I will tell you what I've got here. Here we are. First bit of code here initializes the stack pointer, and then second bit of code is the beginning of the loop. So think of this as the setup for the program, and this is the main. We're basically incrementing a register, and then we are pushing that register onto the stack, and we are calling a subroutine in the monitor, which will display that on the display down here. We're then loading up the number hex value 1800 into a register and going to another subroutine in the monitor that's going to wait out the time. The bigger this 2-byte number is, the longer the wait. Then when we return from subroutine, we're going to pop register D, which was earlier pushed onto the stack, so now it's pulled off of the stack, and we're starting all over again. So it's gonna increment that D, push it, display it, delay it, pull it, and loop again. So that's what you see going on right here now. Let's take a look at that. And let's see, substitute memory 2000, which is where the user memory starts. And next, here's our code. And when we get to 2008, this is where we load where we're loading that 2-byte register with, remember it was 1800. In this particular case, I've actually changed the number to 00. Oh, look at that, it went too fast. Reset. Substitute memory 2123. Next. There's the load. There's a 00 and a 22. So I was putting 2200 instead of 1800. So let's actually increase the size of that to and this is it's a low byte, high byte. So we're looking at the high byte now. So let's change that to FF, and it should slow this down significantly. And hit the next button, reset, go 2000, execute. There you go. It's going slower. Reset, substitute memory 2008. Next, there's a load. There's the 00, the low byte, high bytes FF. So let's just make this make it 00. Okay, and next, reset, Now we have the delay is going to be 2000, execute. I obviously did something wrong. Reset. Substitute memory. 2000. Next. 7. There's the load. 00. Oh, 0000. You know what? It's counting. It's incrementing. So it went from 0000 to or let's, you know what? Let's change this to an 01. And then next. And then reset. And go 2000, execute. There you go. So quite a bit faster. When it was on 0000, it was actually, it was when it went to do the count, it was I haven't read the subroutine, but obviously it was probably decrementing and then going to FF and then going from there when and then not checking for 0 until after it decremented probably. So now I put it on 01. It probably decrements, checks for 0, and then returns from subroutine. So anyway, that's as much as I know about 8085s. Have a good day.